Have you ever wondered how seemingly harmless interactive elements on a website could become a gateway for malicious code to take over your browser experience? A DOM-based cross-site scripting, or XSS, attack executes directly within the victim's browser by manipulating the document object model, or DOM, environment in an unexpected way. This happens entirely on the client side, after the page has been delivered, making it distinct from traditional reflected or stored XSS. The browser itself processes malicious data as legitimate script due to client-side code vulnerabilities. The core mechanism of a DOM-based XSS attack relies on the client-side script taking untrusted user input and writing it back into the DOM without proper sanitization. Unlike other XSS types, the vulnerability isn't in the server's response to the initial request. Instead, it lies in how client-side JavaScript handles data within the browser environment. The server might send perfectly clean HTML, but a malicious script then runs because client-side code uses an unsafe DOM method to dynamically update the page content, allowing the attacker's payload to become part of the active DOM. For an attack to succeed, malicious input must flow from a source to a sink. A source is a DOM object that can be controlled by an attacker, such as document.url.fragment or document.refer. A sink is a DOM object that can execute dynamic code, like document.write, inner HTML, or location.replace. An attacker might craft a malicious URL fragment containing script code. If the application's JavaScript reads this fragment and then directly inserts it into an element's inner HTML without validating the content, the browser's parsing engine will interpret that inserted content as executable code. This client-side vulnerability means that even robust server-side security measures might not prevent a DOM-based XSS. Developers must be vigilant about the source of data that can be manipulated by attackers and the sink DOM functions that can execute dynamic code. Understanding these roles allows for proactive client-side sanitization and validation. For instance, always encode or sanitize untrusted data before using it to modify the DOM, especially with methods like inner HTML, and restrict the use of JavaScript functions that parse HTML strings. Ultimately, recognizing the client-side nature of DOM-based XSS execution empowers developers to build more secure web applications. By carefully validating and sanitizing all user-controllable input before it interacts with the DOM, you ensure that malicious scripts cannot dynamically inject themselves into the page, safeguarding user data and maintaining the integrity of the application's behavior within the browser.
If this helps you code smarter, like, subscribe, and stay tuned for more.